Or you can let everyone in and get them started on the Kahoot. You just log them in. Hi everyone. If you can get started with the Kahoot, just I can copy the link, put it in the chat. You guys can log into the Kahoot. We're not going to play it right at the start of class, but when it's about like 6:50 or so, we can get started with the Kahoot right away. All right. So if you can get in, that would be nice. While we wait for more people to come in. Hey, thank you, CC. Whoever that is. So today, before we start, I'd like everyone to turn on their cameras if that's available, and I'm just going to go through every name one by one. If you can unmute yourself or type the answer in the chat. I just want to go over the times table really quick. So if everyone can unmute themselves, we can go through this really quick. All right. So starting with you, Ada. Uh, can you tell me what 1 times 1 is? We're just going to go down the row. What's 1 times 1? Because it's very necessary for our class today. You can either type it in the chat. So what is 1 times 1? Ada, can you answer, please? Ariana, I'll be asking you next.
Yeah.
What's 1 times 1, Ada? I just heard you talk. Exactly, it is 1. What about Ariana? What is 1 times 2? We're trying to speed through this, okay? So if you can answer really quick, that'd be nice. So what's 1 times 2?
2.
2, exactly. 1 times 3. We're making this.
3.
Pardon?
3.
3, exactly. Next we have Jin Yan. Is that your name? What's 1 times 4?
No, I think it's Ryan. It's Ryan. I forgot to
Right.
change it.
Oh, okay. So, Ryan, what's 1 times 4?
1 times 4, 4.
4, exactly. Next, I think we have Henry. What's 1 times 5?
5.
5. Good. How about Renzo? Is that how I pronounce your name? What's 1 times 6?
6.
6, exactly. Ada, back to you. What's 1 times 7? You guys can all keep yourselves unmuted so we can make this really, really quick. Because there are in total, I think, quite a lot of numbers really. We're just doing the tens table for now. What's 1 times 7? Ada? Can everyone unmute themselves? That way we can make it quick. What's 1 times 7, Ada?
7.
Correct. William, what's 1 times 8?
8.
8. Okay, Ariana, 1 times 9.
9.
Oh, okay, I'm asking William. What's 1 times 9?
William.
William?
1 times 9.
Oh.
9.
1 times 9 is 9, yes. And 1 times 10 is 10. Okay, so that's the ones tables. Can someone give me another number, please? Because the ones, they seem pretty easy, right? Let's go with another one because we've got to be very, very fluid with this. 3. Okay, Nancy, great number. Let's try, I'll ask Ariana. What's 3 times 3? I'm making this slightly harder. So what's 3 times 3, Ariana?
9.
9, correct. Henry, what's 3 times 6?
18.
Correct. Kevin, what is 3 times 7? Kevin, are you here?
3 times 7.
Yes. Well, I was asking Kevin, but you can take it, Henry.
Oh, all right. 21.
Correct. Ryan, what's 3 times 9?
27.
27. Jiren, try this one's slightly harder. What's 3 times 12?
24.
3 times 12. No,
36.
not 2 times 12. 3 times 12.
12.
Yes? It's so if I put 3 12s, it would be 30 what? 36, right? Is it 36? Okay, Emma, what? Okay, can someone give me another, please? Yes, it is 36. Thank you, Ziren. Um, can someone give me another number, please? Maybe a little bigger than 3. 5. Okay, Nancy, you're a no random number generator today. Um, so Ryan also gave me 7, so let's try 5 times 7. Ava, can you give me what 5 times 7 is, please? If everyone can please unmute, that way we can make this really quick. Because for today's lesson, it's everything to do with multiplication. Ava, can you tell me what 5 times 7 is? Ava-san? Okay, Ariana, I noticed you were unmuted, so can you tell me what 5 times 7 is?
45.
35, correct. What about 7 times 7? Emma? I'm asking Emma. What's 7 times 7?
49.
49. I think that's one of the harder ones. It's hard. It's a very uncommon number because it looks prime, but it's not. I'll talk about that later. Um, okay, I'm gonna ask Ryan. I think one of the harder ones too. What's 9 times 9?
81.
9. Okay, I think you guys are all pretty good at this. So if I assume everyone, we can all spit out the multiplication table and whatever numbers I give you, you can just go, what is 9 times 7? Someone please, what's 9 times 7? Ryan?
63.
Good.
I mean, oh yeah,
Yes,
yeah.
it is 63. And thank you, Jiren. It is indeed 63. So the reason I'm starting today's lesson with a bunch of multiplication and like asking everyone to do multiplication factor is actually part of something we're going to be learning called factoring. So what you guys were basically doing was taking a few numbers and then multiplying them to create a bigger number, right? Factoring, I'm not sure if you've learned this before, but it's like a special form of division. So if we look at this, can everyone see my screen? It's in like it's like a textbook form right now. Ryan, can you see my screen?
Yes.
Yes, thank you. So factoring, let's start with this exercise here. As you can see, this exercise, it starts with some of the first few numbers, 1, 2, 3, 4, 5, 6. 1 is pretty boring, right? It's just 1 times 1. Everyone knows that. It's 1 is just 1 times 1. 2. Can someone tell me how you can make 2 with like a multiplication equation? Ryan? So for example, in this exercise, to give 1 times 2 as an example, but I could also tell you that 2 is equal to 2 times 1, right? Can you tell me
Yeah.
what 3 is, Ryan? So how would you make a 3, as in this example over here? Like
Then
using,
3 times 1.
yes, you can use 1 times 3, or as you said, 3 times 1. Ariana, can you tell me how to make a 4? How would I make a 4 in like with a how do I make a rectangle using some numbers basically? You can look on the screen. So on this line I highlighted over here.
2 times 2.
Or so 2 times 2 is one way. Or
1 times 4.
1 times 4, or what's another way?
4 times 1.
Exactly. Let's move on. What about 5? William, can you tell me how to make a 5 using like integers? These are what we call them, or natural numbers really. So how would I make 5? William, are you here? Okay, I'll ask Emma then. Can you tell me how we can make a 5?
1 times 5.
1 times 5, or
5.
so you can make it with 1 times 5, or you can flip them around, right? So we know that 1 times 5 is the same thing as 5 times 1. What about 6? Can you tell me how to make a 6, Emma? You can also look on the screen. So like what are the
2
factors?
times 3.
All right, you can use 2 times 3, or well, what's the other one?
1 times 6.
Exactly. So those are the examples shown on screen. Let's try and see if we can push it up all the way to 20 as the examples on here show. Let's try 7. Who'd like to do 7? Have any volunteers who'd like to do 7? Henry, would you like to try making a 7? So what are ways 7 can be expressed? Or like how do you write 7 equals 1 times 7 or 7 equals 7 times 1? How many ways are there? So if you're following Henry, in this exercise, we're looking at ways you can make 7 using a bunch of using a rectangle, basically. Henry, are you here? Okay, well, I'm moving on next to Kevin. How can you make a 7, Kevin? Okay, Ava says 3, is it 3 times 4, 3 plus 4, or what? So I'm not talking about addition here. Today we're just talking about multiplication. So yes, Kevin says 1 times 7. What's the other way? You can take one row of 7s, or you can take seven rows of 1, right? What did you mean, Ava? What's 34? Is it 17 times 2 or something else? Okay. Ryan, I noticed you're very eager to answer questions. No problem, Ava. I notice you're very eager to answer questions. So 8, I think, is one of the special numbers that has quite a bit of dimensions. Can you tell me like how many ways you can make an 8?
So the first way, 1 times 8. Second
Mm-hmm.
way, 2 times 4.
Mm-hmm.
Third way, 4 times 2.
Mm-hmm.
Fourth way, 8 times 1.
Exactly. Okay, very nice. How about 9? I think Jiran, you're next. You can type in the chat if you want. So, whoops. How would you make a 9? So you can make 9 with either 1 times 9 or 9 times 1.
1 times 9.
Or 9 times 1. And then I think Kevin typed 3 times 3. Thanks, Kevin. But can you let Jiren do it? So because I asked him to. Yeah, thanks. Um, Jiren, since Kevin answered the half of the question for you last, can you tell me how you can make a 10? How do you make a 10? So
5 times
5 times 2.
5. 2. 5 times 2.
That's 1. What's the other?
1 times 10.
1 times 10, exactly. And then you
10
can flip both.
times 1.
And I think that's only 3. So there was 2 times 5, 5 times 2, 10 times 1, and what's the other one? It's actually one of them is the same. It's just the numbers are flipped around. The other one would be 1 times 10, or it was 10 times 1. There was a pair. What do you guys sort of understand this concept so far? Like, do you kind of know where I'm heading at? We're just trying to take numbers and breaking them into their parts, or into parts you can make with rectangles, basically. Oops, that's a bit much. So if we look back on the screen, what I'm talking about, like when we're making parts, is that if I give you a number, say 6, for example, um, like if we look at the second example here, we see that 6 has 2 factors, or not 2 factors. It has I think in total has 4 factors. As it can be divided by 1, right? It can be divided by 6.
It's 6.
It can also be divided by 2, and it can be divided by 3. So we see that 6, it can be equal to 1 times 6, or it can be equal to 2 times 3. So when I ask you, for example, what are the factors of 6? You would tell me that 1 times 6, 1 and 6, those are 2 of the factors. And then 2 times 3, those are the other 2 factors. So um, as we can see here, when 2 or more numbers are multiplied, it doesn't need to be 2. You can throw in another number. for example, 8, right? You can throw in 2 times 2 times 2. That's also valid, right? So 2 times 2 times 2, that would be equal to 8. And we see here that's a whole number that has exactly 2 unique factors. One, and the number itself is a prime number. So, have you guys learned prime numbers yet? Because most of our lesson today is going to be about prime and composite. William or Kaden and Kelly? Kinda? So can you tell me, if you can unmute yourself, Emma, can you tell me what you know so far about prime numbers?
Nothing.
Okay, so Caitlin, you don't really know about prime numbers yet. Ryan, what do you know about prime numbers?
So prime number cannot be like a rectangle. Like when you do like a table, it
Hmm.
cannot be a rectangle. Like it cannot. If you divide the prime number, it will always have a decimal of
Right.
it.
So if you take out your calculator and go like, I'm just gonna divide this by some number, you're always gonna get some really, it's not gonna look ugly usually, but there's always going to be a decimal after it if it's not divided by either a 1 or by itself. Is that what you're getting to, Ryan?
Hmm? Pardon me.
So like when you take out a calculator and you do the division, like if you take another number that's not 1 or that prime number and you divide it, you're always going to get like a dot something 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 something. Yes,
Yes.
so I think you get the point, Emma. You can only multiply by 1 or itself. Um, so let's make a number line over here. Let's start with 1, okay? I think one of the most confusing parts about prime numbers is asking whether 1 itself is a prime or a composite. So I'm going to list a table here. We have prime on one side and we have composite on the other. Can you guys all draw a table? So like, can you all guys all draw on the screen so right now? Like, can you guys all draw? Like, draw check marks or anything? Is that allowed? Okay, so I think Ethan can draw. Ryan, yeah, okay, I can see you guys can draw. If you guys can do what Ethan's doing, just putting a green check mark, that would be great. So, um, one thing we have about prime numbers, the first thing the first thing about prime numbers is, well, when we start with these numbers, we usually start at 1, right? Um, so when we're doing check marks, you have to go down to the stamp button. There's a stamp button. If you click on it, there's a check mark. You can just go around and click check marks everywhere, just like that. Okay. So if you guys can use that feature, that'd be great. Okay. So back to the lesson. So well, let's look at the definition of a prime number. Okay. It says a prime number is a number that has exactly 2 unique factors, 1 and the number itself. So if you look at the definition, this number needs to have 2 unique numbers. Okay, I'm drawing here. So if it has 2 unique numbers, oh, come on. It has to have 2 unique factors. And what that means is, let's say you have some number, okay? It needs to be multiplied by some A, some number A. You gotta multiply it by some other number B. It can't be the same number. So let's look at 1. We know that 1 is divisible by 1, right? So that's true. And it's also divisible by itself, which is also 1. So that's also true. But if we look at the condition, it says it has to be divisible by 2 unique factors. So because 1 is equal to 1 times 1. Everyone agrees on that, right? 1 is equal to 1 times 1. But 1 and 1, they're exactly the same thing. They're not unique. So when we look at 1, mathematicians, we usually label 1 as neither. It's not prime and it's not composite. So it only has one factor and it's not prime either. So it's not composite and it's not prime. So in this case, if you guys are doing check marks, you should be checking the n square down here. What about 2? Can someone tell me whether 2 is prime or composite, please? Um, yeah, Ryan, I'd like you to just check mark, please. Yes. So why is everyone choosing 2 right now? Sorry, I mean, why is everyone choosing prime for 2 right now? That question was worded a bit. So why is 2 a prime? Can someone explain why 2 is a prime? Yes, Ryan?
2 is a prime because it have two factors, which is the which is 2 and 1.
Exactly. So if we look back at the definition, a prime number has 2 unique factors, right? If we looked over here, you did mention it's divisible by both 2 and both by 1. So that's 2 unique factors. That's satisfied. 1 and the number itself. So this is check. It's also divisible by itself. So that's check. Because it satisfies these conditions and it's not divisible by any other number, we know that 2 is a prime. What about 3? Is 3 a prime or not prime? I'll clear all the drawings and you guys can start checking. Oops, sorry. I just got rid of some. So yes, I believe everyone is choosing prime again. So why is 3 a prime? Someone other than Ryan, please. Emma, can you tell me why 3 is a prime?
You can only times it by like 1.
Exactly. So it can be divisible by 1. What other number can you divide it by?
3.
3. So does it satisfy the constraint? Well, not constraint, that's a bit. So is it a prime number? If we look at the definition,
I guess.
it is a prime number. What about 4? Is 4 a prime?
No.
No, why not? I mean, all these numbers have been prime so far. Why is 4 all of a sudden not a prime? Ariana?
Because 4 can times 2.
Yes. So 4, you can divide it by both. We know that 4, it's equal to 4 times 1, right? That's pretty trivial. But 4, it's also equal to 2 times 2. And we see that a number greater than 1 with more than 2 factors, see this, more than 2 factors is a composite number. So if we look at the factors of 4, we have 1, right? Every 1 divides every number. We also have 2, and then we also have 4. And how many numbers are there? We have 1, 2, 3. There are 3 numbers here, right? So is 3 greater than 2? Is 3 greater than 2, everyone? Well, of course. 3 is greater than 2, or else I am living in a completely off-sided world. So we see that 4 has more than 2 factors, so 4 is a composite number. So you guys got this one correct. What about 5? Is 5 prime, composite, or neither? Ryan, Ariana, I know you guys have both been pretty active. I'll let Ada answer the question. Is 5 prime or composite? Ada, can you tell me whether prime is a composite number or a prime number? Okay, do I have any other volunteers? Maybe Henry? Henry, can you tell me whether 5 is prime or composite?
It's a prime number
It's a prime number. Why is it a prime number?
because it can only be divided by 1 and by itself.
Exactly, it can be divided only by 1 and itself. Okay, I think this is getting a bit too easy for you guys. So let's make these numbers a bit harder, all right? Let's get rid of 5, get rid of 4, get rid of 3, 2, 1. Um, let's go with a bigger number. Let's say 21. Let's try 21. So is 21 prime, composite, or neither? I'm going to erase a bit more stuff. Uh, so I see a few people are choosing composite. Why is 21 composite? Or why is 21 prime? If I know Ryan, you just prime.
No,
But
actually, I accidentally did it on the wrong place.
oh, okay. Well, don't worry. Can you explain your answer? I don't just want you to put a check mark and then fall asleep. So I want an explanation. Why is 21 prime? I mean, it looks like a nasty number. It doesn't look very friendly. It's odd and it it's like 20 plus one or something. it doesn't look like it's divisible by numbers. So why are people choosing composite, Ryan?
Because it have more than two factors.
Okay, what are its more than two factors other than 1 and 21? So we know that 21 is equal to 1 times 21. That's obvious. What other numbers are divisible by?
3, 7,
Mm-hmm.
and that's about it.
Yes, so it's divisible by 1, 3, 7, and 21. So if I were to ask you right now, what are the factors of 21? Can you list them? So they are, as you just saw, they're 1, they're 3, 7, and 21, right? They're the numbers that make up 21, right? So in this case, you would, try breaking it down as much as possible into its prime counterparts, and then you'd get the answer of the factors of 21. Okay, so instead of 21, let's try another number. I'm gonna clear all the drawings here. Um, let's try 39. Is 39 a prime or a composite number? Okay, Nicole, can you tell me whether 39 is a prime or is it a composite number? And yes, Emma, we are doing Kahoot. Uh, if you haven't seen at the top, the Kahoot link is in the chat. So we have quite a lot of people choosing prime. Why is 39 prime? Oops. Okay, we have one loner choosing composite, so it's 3v1. Can someone tell me why 39 is a prime number? Okay, Ryan?
Pardon me? Like, could
Uh,
you question again?
so can you tell me why 39 is a prime number? I see lots of people are choosing 39 as a prime number.
Actually, it's not prime, it's composite.
Oh, so it's not prime right now. Why is it composite then? Can you explain?
The reason it's composite because it have like many factors, like 1, 3,
Mm-hmm.
mm,
And then what?
13, 13,
13. Mm-hmm.
and that's it.
That's it. So there's also
And
39.
39
Of
itself.
course, there's also 39 itself. So we can factor 39 as 1 times 13, or we can write it as 3 times 13, right? So I think lots of people fall for that trap. It doesn't look very, very nice. So you might be like, oh, that's prime. It's prime. But um, this is a place where I would actually like to introduce some non-textbook stuff. If I were to give you some really big number, okay, I'm just going to type a random number in the chat right now. Can you tell me whether that number is divisible by 2 or not? Okay, this is literally a random number I just typed in the chat. Is this number divisible by 2?
Yes.
Why is it divisible by 2? Like, did you do the math? Did you take out a pencil and started going like, okay, was this 1, 2, 3, 4, 5, 6, 8 divide by 2, carry that? Did you do that? I don't think anyone did that. That would be ridiculously fast if you did. How do you guys all know it's divisible by 2 so fast? And can someone tell me the trick? Ah, so Kevin, you spotted it does have an even number at the end. So we see that any number with an even number at the end, and that includes 0 as well. We know that, for example, if you have some giant gibberish stuff, and at the end you have either a 0, a 2, a 4, a 6, or an 8, then that number is divisible by 2. Okay? This is very useful to know. Whenever you see like I know in high school mathematics, any mathematics, if you see these kinds of numbers, you know it's divisible by 2. All right. So if you see any of these 5 numbers at the end, it's divisible by 2.
It's 6:30.
For this rule, it's actually pretty easy. You just need to know these 5 numbers, and then you can just tell me, aha, even this random number you just typed in, it's divisible by 2. Uh, okay. So if a number is divisible by 2, you just got to look for these 5 numbers. But what if you wanted to know whether a number is divisible by 3? I'm going to type in another random number in the chat, and let's see if, okay, Ryan, I think you might know the trick already, but don't spoil it. I'm gonna type in another random number. It might take everyone a bit longer, but see if you guys can figure out whether this number is divisible by 3 or not. You think so, Kevin? Okay. Well, we have a few people saying yes, few people saying no. No, no, yes, yes, yeah, yeah. Well, okay, first to the yes people. Kevin, I'm gonna pick on you, just because you were the first. Not for any other reason. Why is this big giant random number I typed in divisible by 3? Or what's your explanation? I literally just randomly typed it in, so I didn't even check or anything. Okay. If you don't know, I'll ask Emma. And can you tell me why this number is divisible by 3? Emma? Emma, are you here? Okay, if Emma is still typing, I'll ask. Okay, Ryan, you can spoil the secret now. Why is that giant number not divisible by 3?
Because like the way like if you actually there's a trick, like you just add all the digit up like
Mm-hmm.
to the sum and then
Mm-hmm.
and then see if it can be divided by 3. Like
Ah, okay.
when you add all these digit up, it's 40, but it cannot be divided by 3.
Aha. So 40 is not divisible by 3. I think you actually did the addition, but um if the reason this works has to do with some higher mathematics, but what you just said is correct. It works for 3, but it also works for 9 as well. I think lots of people don't know that it also works for 9. But for 9
Oh
it's a
yeah.
bit special. It needs to be divisible by 9 for it to work. So just as an experiment, can someone give me a decently small random number, just 4 digits? I'm just gonna try and prove it, well, with real numbers to you, given some random number. So, okay, Kevin, you gave me 4352. So just using the trick Ryan just taught us, is 4352 divisible by 5? Oh, sorry, not 5, divisible by 3. So the trick would be you break the number into parts, right? And then you add them up. So for 4,352, you can break it into 4 plus 3 plus 5 plus 2. And can someone tell me what the sum of this is? What's 4 plus 3 plus 5 plus 2? 14. And is 14 divisible by 3? No. So it seems like 4,352 isn't divisible by 3. But what if Ryan lied? Well, let's try checking it the real way, okay? So, just to make sure Ryan isn't tricking us, or I'm not tricking everyone. You guys can all take out a piece of paper and try doing the math yourself. So 4,352. What would I put in the hundreds, in the thousands spot? What would I put over here? 1, okay. And then what do I do next, Kevin? So I take the 1 and then I bring it. What do I do? I would multiply by 3, bring it down here. So then I can, right? So I can subtract 4,352 by 3,000, bring it down here to 1,352. Okay. After that, what would I put down here? What would I put in the seconds, in the hundreds spot? Yes, Ryan?
So you put like 4
A 4, exactly. And then what next?
and then you like put 12 under 13 and then
Mhm.
subtract it
Okay, so I put
and then
12 under the 3, and then what do I get next?
15
Right, 13 minus 12, I get 152. And then what do I put next? Over here in the 10 spot. So what is 15 divisible? Is 15 divisible by 3?
Yes.
Yes. So what would I get? What would I put in the 10 spot? 5. Okay, Kevin put 5. So I'm gonna put a 5 over here. Then what do I do down here? Okay, I'm just gonna bring this up a bit. So I have 152, 52, and then 3 times 5 is 15, so I subtract another 15. And then in the end, what do I get? I get 2, right? So is 2 divisible by 3?
No.
Nope. So we see that 2 is not divisible by 3. And what's something interesting here is, if you look at the 14, let's try dividing 14 by 3. If I divide 14 by 3, what would I put at the top?
4.
4. So what's 3 times 4?
12.
12. And then what's the remainder?
We made a 2.
2. Oh, look at this. We got 2 here and we got 2 here. So something interesting is if you do the sum and you find out it's not divisible by 3. Okay? If it's not divisible by 3, you can actually find the remainder really quick. You don't need to do all this math I just did. You can, find the sum. You just found it's 14, and the remainder is actually just 2. You see both of them were 2. 4,352 divided by 3, the remainder was 2. 4 plus 3 plus 5 plus 2, that was 14. You divide that by 3, the remainder was also 2. So this has another trick. If you take any number and you try dividing it by 3 with any method, you can sum all its digits and then divide it by 3 and then find the remainder. Or you can just do it the long division way, but the remainder is always going to be the same. So no matter what number, even if you use this fun way of just this really quick way of just summing the digits all together, you get the same remainder. So now we kind of know how to divide by 3, right? The fast way to divide by 3 is just add all the numbers together and then see if that number is divisible by 3. And even if the number is really, really long, and then you add them all together and you still get a really long number, you can do the same process again. You can add up all the digits. So for example, let's say 14, okay? You can add up 14. What's 1 plus 4?
5.
5. So 1 plus 4 is 5. And is 5 divisible by 3?
Nope.
No. So 5 isn't divisible by 3. If you divide it by 3, you also get a remainder of 2. So you see that this remainder of 2, it just carries on all the way down. So this actually applies with every single number that exists, basically. So when you divide by 3, this actually comes from how this rule was derived from. This addition, adding by 3, it didn't come out from nowhere. So if you can do this both with 3s and both with 9s. But with 9s, you got to make sure it's the number you get is divisible by 9. Okay. Okay. I'm gonna skip 4s because that takes a bit of explaining to do. It's actually pretty easy as well. But can someone tell me how you can check if a number is divisible by 5? Okay. Let me just type a number into the chat real quick. Give me a second. So is this number divisible by 5? Oh, I think I sent it to Ryan. But I'm just gonna send another again. Something very similar. Can everyone tell me whether this number is divisible by 5 or not? Ariana says yes. Okay. Kevin says yeah. All right. Jiran also says yeah. Emma says I guess. Emma, can you tell me why you think that weird number I just put in is divisible by 5? Or Jiran, you can tell me as well. Why is that giant number? Why is it divisible by 5? It has a 5 at the end. So just like a 2, you see that both with fives and the 2, you need to look at the ending number, right? If I have some giant junk over here, and then at the end I have either a 0 or a 5, then we know that this number is divisible by a 5. Yes, Emma, you are correct, because it has a 5 at the end. If I switch it out, let's say I put in some giant number, threw in a 0 at the end, is this divisible by 5?
Yes, sir.
Aye, it is divisible by 5. So you guys can tell just by looking at that number is divisible by 5. Okay. Now let's skip this example since we already did quite a lot. We're going to try learning about prime factorization. Okay. So can everyone see my screen? I just cleared all the drawings. Um, okay. Do I have any volunteers who would like to read this part, please? Ada, can you read the highlighted part on the right? So this part.
Yeah.
Yeah. Okay. So starting with over here, every composite number.
Huh?
Can you read the box that is highlighted by Nancy, please?
Every compost number can be expressed
Expressed.
as a product of prime numbers. This is called a prime
A prime factorization.
factorization of the number. A factor tree can be used to find a prime
Factorization.
factorization of a number.
Okay. All right. Let's look through let's look through this section again. Thank you, Ada. Um, there's some key terms you guys need to know. Can someone tell me in the chat or unmute yourself? What do you guys think a product means? So I know in terms of business, a product is a thing you make, right? Like this is a product I think Casio makes. But in terms of math, what is a product?
The answer?
Okay, who said that? So, okay, Emma, so you're sort of correct. The product is the answer, but it's a specific answer. For
The
example,
like
yes?
the a product is like a marble cake. The answer for marble like
Aha. Yes. So I think Ryan, you're more specific here. The reason, so when we talk about the answer to a math equation, there are actually lots of different terms you can use. But in terms of multiplication, if I asked you, just, in the spirit of this morning, well, not this morning, like at the start of this lesson, if I asked you what is 6 times 7, and I asked you to fill in the blank, you would give me the product. But if I asked you what was 6 plus 7, the answer you would give me is called the sum, right? So, or if I asked you what is 12 divided by 6, you would be giving me something called the quotient. That's a bit of a difficult term, but um, yeah. So the product is the answer you get when you multiply two or more numbers. It's just a specific term to tell you that we're multiplying numbers to get a bigger number. And well, in our cases, it's usually a bigger number. So today I realize we're getting in the lesson rather late, but today I'm going to be teaching you how to factor a really big number. We'll start small, okay? Let's look at this example. So it tells us to find the prime factorization of 54. Ariana, can you walk through the steps for me, please? So starting with this blue square here.
Write the number that's being factored at the top.
Okay, so we see here that it's 54. I'm going to give you another number. Let's try uh, uh, let's try 42. Okay, so we're going to do our own example on the side. So we just wrote the number that is being factored at the top. And then what's the next step, Ariana?
Choose any pair of whole number factors of 54.
Okay, so we see here on the left, there's a 2 times 27, and on the right, there's a 3 times 18. Both of them work. So 42. Can you tell me what number divides 42, Ariana? Just by looking at this number over here?
2.
2. Exactly. So we can throw in a 2 over here. And what number would go down here? So notice these two numbers, they multiply to give 42. So a number
21.
exactly. So 2 times 21 is 42. Is 21 prime or composite?
Composite.
Composite. So if it's composite, what numbers divide into it other than 1 and 21?
3 and 7.
Thank you. It is indeed 3 and 7. And thanks to Kevin and Emma in the chat. I've been watching it. We are going to play Kahoot at 6:50. So if we look over here, we already checked that 2 is prime, right? What about 3? Is 3 prime? Is it composite? Anyone can answer in the chat or by unmuting themselves.
Prime.
Prime. And what about 7? Is 7 prime or composite?
Prime.
Prime, exactly. So we see that 42, we just factored it into its respective prime numbers. So we can write 42 as 2 times 3 times 7. Okay, so none of these numbers are composite. We know they're all prime, so we can't break it down any further. Otherwise, we just get a bunch of ones, and we still have the same group of numbers over here. And we see that, continuing down is just continue to factor any number that's not prime, which we did over here, right? And then except for the order, the prime factors are the same, which I'm pretty sure everyone knows. Right, Ryan, you are correct that are not whole numbers. But over here, we are only playing with whole numbers. If we threw in some decimals, it's just we don't like decimals in grade 6. Okay, decimals they're hard, and honestly, I detest them. If I'm being quite honest with you. So in this case, we're just playing with whole numbers, and if we break down 42 into its prime factors, all we get is 2 times 3 times 7. That's all we're gonna have. Okay, can someone in the chat, Nancy, I'm gonna trouble you again to give me another random number that has more than 3 prime factors. Okay. Well, 3 or more. So do I have any volunteers who'd like to factor this next one? Okay, I'm gonna try. All right, Ryan. I'm not blind, but I'll come up with, okay, let's try 54. Oh, we already did 54. Maybe I am blind. Let's not do 54. Let's just do 27. Okay. Um, okay, maybe not 27. 27's on the screen too. Okay, let's just do 64. All right. 64. Ryan, what's the first step to factoring 64?
The first one is 2,
Okay, so you can divide 64 by 2.
and
When
then the other one is 32.
2. Okay, so 2, I'm pretty sure we've already checked, is a prime number, right? So it just ends over there. What about 32?
And then 32, the first factor 2, the second factor 16.
Uh-huh.
And for 16, the
So 2
first
is
factor 2,
mm-hmm.
the second factor 8, and for 8, the first
Mm-hmm.
factor 2, and the second factor 4, and for
Yes.
4, first factor 2, and the second also 2.
Okay, so we've broken that down, and we see it's just 2, 2, 2, 2, 2, 2. Right? How many 2s are there, Ryan?
6.
6 2s. So we see that 64 is equal to 2 times 2 times 2 times 2 times 2 times 2. Okay, that's it. And we're done with my musical singing practice. We see that there are 6 2s. And if you're a mathematician, you don't like writing it this way. This way is very hard. And I noticed we're running out of time. We only have 10 minutes left. We can start the Kahoot very soon.
Wait.
But just as a lead up to next lesson, Ryan, do you know any exponents? Do you know what exponents are?
Yeah,
Yes?
2 to the power of 6.
Exactly. We can write this very easily as 2 to the power of 6. So before you ask what that means, we will be covering it next lesson. Because if I just scroll down 2 pages on this PDF, you will see that it is indeed oh, I missed it. Our next lesson will indeed be powers and exponents. So because mathematicians, we're actually pretty lazy. We're not lazy in terms of we don't like to do work, but when you need to write out really, really long things like that, exactly, I just wrote 6 times. It's quite a lot of work. You might as well just put a 6 on the top, right? So our next lesson will be about exponents. So we will indeed be getting started on our Kahoot. So if you guys have all signed in, we can get started. Are you guys all in? I'm gonna clear the drawings so that the screen isn't polluted by my horrible writing. Since I assume everyone's gotten in by now, let us begin. Oh, sorry. Nice. So I'm pretty sure everyone who is playing right now has paid attention to class. Okay, moving on. Okay, so 21, I'm pretty sure we've also covered this in class, can be factored as 3 times 7, right? So in addition to 1 times 21, 3 times 7 is also equal to 21. So just in case you don't know that, keep that in mind, all right? Because composite, they're numbers that have more than 2 factors, and prime, at most, they only have 2 factors. Okay, let's move on. Nice. I think everyone got that right. So 10 can also be 2 times 5. Oh, I covered this really early. Okay. It is in fact neither. I know at one point in my life, I think at about grade 5 or 6, would also have argued that it's prime. But the reason it's neither is because when you write one out, it would be equal to 1 times 1, right? So 1 is equal to 1 times 1. It's divisible by 1, and it's also divisible by itself. That's what I would argue. I'm like, see, 1 is divisible by 1 and 1. So it's a prime. But 1 and 1, they're not unique. 1 is the same as 1. It's not different from 1. So it only has 1 factor. It doesn't have 2 factors. Prime numbers, they have 2 factors. And because 1 only has 1 factor, it's not a prime. That's the main justification behind it. It only has 1 factor, therefore it's just not a prime. It doesn't satisfy the conditions. Okay? So in this case, it would be neither. It's not composite either because we already know it's closer to a prime theoretically, but it's just not a prime. Okay, it doesn't have 2 factors, so it's not a prime. Let's move on. Okay, Ryan, she ran on the lead. I'll get rid of this. Oh, I've got to cover this in class. Sorry, guys. Okay, sorry to the guy who didn't know, but 0, in fact, it's neither. It's divisible by like an infinite number of numbers. You can throw any number, 0 divided by any number is still equal to 0. So that might make it look like it's composite, but just by the rules of math, it's actually just It's just neither. All right. I'm sorry. I didn't mention this in class, but I guess most of you kind of guessed. It's special, right? If you look at zero compared to all other numbers, it's zero, both zero and one. They're one of the most special numbers in number theory and in pretty much all math, right? I mean, if you go on a math test and guess an answer, you would probably just guess zero. Um, that's not the smartest answer, but if you were really that clueless, zero would be your best guess, really. So, um, that's just it. Okay, you're gonna have to need to use your division rules here. No way are you gonna do the long division this fast. Okay, it is indeed composite. It's not prime. If you look at the end, there's a 6 at the end. And since 6 is divisible by 2, we know that this, you don't need to care whatever numbers I put in front of it. There's a 6 at the end, so it's divisible by 2. And because of that, there's more than 2 factors, so it's composite. Okay, that is moving up. Oh, so by twin primes, I mean numbers that are both primes. Okay, this one was actually pretty hard. I don't think I should have put it in here, but yes, the correct answer is actually 101 and 103. The reason 47 and 49 doesn't work, if you guys know your times tables, what's 7 times 7? Can someone type that in the chat, please? 7 times 7 is 49, so is 49 prime? I don't think so.
Oh.
So 49 is not prime. 21 we also saw was 3 times 7. And 35. Can someone tell me the factors of 35? Henry? Okay, well, Kevin, you put 5 times 7, so we can tell that 35 is not prime. I'm pretty sure 37 is prime. 47 also is prime. 23 is also prime. So this was actually a really tricky question. 101 and 103, we take a bit of time to verify, but neither of those are prime. So this is actually a really hard question. I'm kind of sorry I put it on. Well, the leaderboard isn't moving much, but we'll see. Okay, double points. Pay attention. We're gonna have to do this really quick. Notice it's a prime factorization of 140. I'm not just asking you to give me like 1 times 140. Okay, that's not the prime factorization. We're looking for prime numbers. Pardon?
I thought like the time is still short, so I just did a quick guess.
Oh, sorry about that.
Sure.
I did give a bit longer time. Wow. So a few people actually got that right. It is indeed 2 times 2 times 5 times 7. For those who chose blue, it does look mostly correct, but if you can break 10 into 10 is composite, right? It's 2 times 5, so you can break it down into the 2 times 5 we see in the yellow answer here. So I'm pretty sure most of the answers are correct except red. So good job to the people who did choose red. Let's move on. Okay. Oh, this one's hard. Just as a hint, you need to use the division by 3 rule. The division by 3 trick we learned today. Okay, good job. So presumably the people who used the division by 3 trick found out that 5 plus 7 is 12. And because 12 is divisible by 3, you found out that 57 is also divisible by 3. So
it's 7 o'clock.
Is that how some of you got blue correct? I know 47. I think the other numbers over here are all prime. So the quickest way to verify this would have just been to add the numbers together, find out most of them are divisible by 3 except for 57. So it's blue. Okay. One more question left before this class is done. Okay, shall we skip? Okay, so I'm pretty sure everyone got this one correct. It is indeed 2. Give me a second here. Okay, drum roll, please. All right, Foxy EB is 3rd. Ziran is 2nd. Good job. And first place is CC. All right. Good job to Ziran, CC, and ED.
Nice.
We also have Ada and Kevin in 4th and 5th, respectively. So you guys all did pretty good. I know there were some really challenging problems on there, but I think those of you who were participating did really good today. So especially Ryan, I'm really glad you participated a lot. You had your hand raised pretty much all the time. So kudos to you, Ryan. Round of applause for Ryan, please. And I'll see you guys all next Monday. So see you all. Have a great week.
Bye.
Adios. Bye.
Bye.
Adios.
Thank you.